Greetings, dear viewers. Today we have a special guest with us. His name is Tapiwa Muvungani. He's been working on the novel technologies to make limitless energy system and overunity generator for the production of unlimited energy. Dear Tapiwa, if you have anything to add, please share with our viewers about yourself.
Thank you very much for the honor. So yeah, it is true. I am Tapiwa Muvungani, and I can safely say I am an energy scientist and a physics enthusiast. Most of the time, of course, I do spend working on overunity machines, as they're called in that field of regenerators. And yeah, I've actually worked with quite a number of people, university professors, who are also equally interested, in that sphere of influence, if I can call it. And yeah, in a way, I am more into the research and development of such technologies. So I simply regard myself as a student, a lifelong learner in that field, because I truly believe at any point in time you regard yourself as an expert, it is a problem because in a way you sort of close up the doors to learning. So I think I can simply be referred to as an energy enthusiast. I like it that way, just to keep it simple. And I'd like to thank you as well for having me here. I really appreciate it.
Thank you so much. We're also very honored to have you as a guest today. And to start talking about your journey, could you please share with us how actually you come up with the idea of creating a fuel-free generator?
Oh, thank you on that one. I think that's one of the best things to have ever happened to me in my life. I think the key moment when I, got the light bulb moment that I should work on this, it was just a day in class. So it was more or less of an Earth Day, a day whereby, people commemorate the Earth and out there to take care of the Earth. So we were watching this documentary by David Attenborough. It's simply called A Life on Our Earth. So in that documentary, he simply explains how he has managed to travel all over the globe. And he also gets to, express, let's say, his perspective on the impacts that humans have had on the planet. And he simply gives a call to action that if there are people out there who think they can do something about it, they should, because basically time is running out. So to me, that just came as a challenge I liked. So I think it was in 2021. By then, I was simply 17 years old. And yeah, I really liked the challenge. And I was like, you know what? What would happen if I just do this? Because the guy is not really requiring people to use lots and lots of resources. He's simply calling people to action. He simply wants people interested, to think about it. There's always power in thought, because I'm a person who believes things exist twice in the universe. First, they exist in our thoughts, then they exist, in the physical reality. So at that moment when, he asked people to do something, I was like, you know what? I am in on this one. And I think I did lots of researches on the field. I was really interested. I ended up writing this research paper on that particular idea, which I was focusing on. It is known as perpetuum energy Lebensraum. So perpetuum is simply like a Latin word, which simply means perpetual energy. I think the way I love to define it is simply a currency of completing action. Then Lebensraum, simply the German word for living space. So in that article, I was simply expressing my thoughts and, my philosophy on the idea of energy and how it's the core of civilization. And it's quite interesting, the scope of things that you get to come across when you're looking in that subject, because you discover you're not the only person who would have thought about such things. Many people have actually thought about it. But then there's the mainstream perception of how it is like, because when you regard the term fuel-free energy, it's quite provocative, in the field of physics, because how can you have, in quotes, free energy? But then I can say sometimes we choose to end up with that conclusion basically because our perception sometimes may not be the right towards the subject. Because the convention of physics, of course, the devices, you discover that most of them, they're classified in three classes. They're the perpetual energy devices of, let's say, the first class, second class, and third class. So how each device or each, let's say, technology is placed into a class, it's actually, let's say, dependent on the kind of law of physics that it sort of defies. So in physics, we've got our unique government. It's called a government, the laws of thermodynamics. If anything just goes against them, or most likely something should be wrong with whatever you're working on. So if it's a device of the first law of thermodynamics, it then simply means that it, in a way, seeks to, let's say, defy the law of conservation of energy. Then if it is a device of, the second order, in a way, it is somehow finding a loophole in the interconversion energy of, the second law of thermodynamics, and it goes on like that. So many people have actually expressed their thoughts on that subject, and some of them are really prolific figures. even Da Vinci himself, he actually had a very interesting quote. I think it was in the 15th century, whereby he stated that any person who seeks to make anything that is in quotes fuel free and yet makes energy, he should place himself amongst the alchemists, or basically in quotes magicians or tricksters in a way. And other prominent figures also had to make really tough remarks on that subject. But then the more you dig deep, the more you discover that no, actually, that's simply one side of the coin. There's also another side of things. There are also a number of prolific people as well, even though they may not be popularized, but yeah, they did quite a number of researches on that. Some of them include Henry Murray, is one prominent inventor who worked in the fields of, zero-point energy. And if you dig a bit deeper, you also discover that people like John Bedini, John Stell, there's quite a little number of people, even people like Nikola Tesla and their technologies on, wireless transmission of energy and the ether. And you discover that it's actually, let's say, in a way, two camps of people, let's say, with conflicting philosophies. Some believes things are the way they are because that's the way they're supposed to be. But then you also have another camp on the other side that says, no, things are the way they're supposed to be because we choose to see them that way. And, that's the sort of perception that those inventors have, that if you choose to look at it in a different way, the universe is powered by sometimes unobservable forces, such that if we are to tap into them, we can actually have that unique energy and be able to power our systems, which is quite a unique perspective. So yeah, that's when I realized that no, this is actually a very murky field, and when you're in it, you actually need to really understand, what you're dealing with. There's this guy by the name of Steve Greer. He's a famous American physicist, UFO expert, and stuff like that. He's one person who spent a lot of his fortune investigating some of these devices. And one thing that he honestly says to most people is, most people claim that they have these technologies. Some of them, 99%, in fact, they may not be technically, let's say, upright or correct, or they may not actually work according to the standard. But then he also states that even though it may not be all of them which work quite well, some actually do work according to that expectation. And he lists out the various fields which I don't know, which actually aid the generation of that fuel-free device. Some of them may include maybe extracting energy from radiant energy, maybe to the currents of the earth, utilizing of the Zeneca wave, there are lots and lots of things about that. So I think from simply studying the greats and just looking at what they did, that just gave me a whole new perspective on the issue. And I think it actually gave me that ability, to simply investigate things afresh with a clear mind. Because it's one thing to look for something once you already have, let's say, an idea in your head, when you have some sort of prejudice towards the subject. And if you do the research again, but this time with a fresh mind, with an attitude of a learner, definitely the results won't be the same. So I can safely say, yeah, those guys who worked on those technologies, the guys who came before me and who did many great things before, I learned from them open-mindedly and I discovered that no, it's actually doable. And following their footsteps, yeah, I also got to find, myself. And I also got to realize that, yeah, I can actually make a range of these devices. It's very possible. It's very doable. And let's say throughout the process, I've always enjoyed it. It's always been a good thing. And that's how I actually got to come up with my first idea. It was learning from observation, then looking within me to find out.
It's very interesting to listen to your observation and what other people were saying and your own conclusion and mindset about this invention. And at that time, you didn't have the knowledge, maybe technical knowledge in the field. Could you please tell us how you learned and where did you get this information from? Perhaps you found other examples of fuel-free generators and tried to replicate them?
So as I said, I approached, the subject with the mentality of a learner. So definitely the first thing that I had to do was to try out the things that those guys, claim that they worked. There's very one famous inventor on my list whom I really respect. His name is John Bedini. He makes very interesting circuits. Some of them, they're popular. For example, the Schumacher circuit. He actually writes, compilations of them. So I actually wanted to verify if this is true because no matter how good something is, you always have to, you don't have to be naive. You always have to be skeptical about things. It's good to be skeptical. It doesn't mean you don't believe, but it simply means you are trying to make everything foolproof. So I was like, okay, let me try these things out. So I think the very first thing that I did was trying out some of the circuits. And to my surprise, some of them worked in a very awkward manner. I wasn't expecting the results, but then, yeah, they actually do work. So to most people out there who may wish to learn about this subject, I think first and foremost, you simply have to understand that not everything is as it seems. It's all about perception, actually. I always say this to most people that as humans, we mostly rely on the sense of sight if we're in the field of sciences, we say seeing is believing, but we also have to take into account that the reality that we choose to make, it comes from, let's say, less than 0.0035% of the available electromagnetic radiation we can get to see with our eyes. So whenever we approach the concepts of science, which may be out there, of course, there's a tendency that we choose to say, if you choose to do this, you are violating, let's say, perhaps a basic principle or a law per se in that field. But one thing we tend to forget is that those formulations of laws and principles, they have to come from observations from people just like us. And there is a possibility that they could have not seen it all, for there is always more to see. So I think that's one thing that I would like to shed light on, that the perception that you have on a subject will actually, let's say, tend to influence things and how they work. Because mostly in the science field, we work with a reductionist approach. We view something, we try to reduce it to a set of principles, laws, and then whenever we see something again, we try to make it fit into those formulations that we would have made. It's not a bad thing. In certain circumstances, it actually does work quite well, but then we cannot safely say it's going to work quite well in all the cases. So you always have to leave room for, let's say, figuring out something new. I think it comes with the willingness to accept alternative views. Our physics teacher always did this to us, he would always tell us about the greats in science, let's say, for example, Isaac Newton or Einstein. Einstein in this special theory of relativity, and one, the general theory of relativity as well, and gravity. You talk about Newton's and his formulations of the laws of gravity and stuff like that. And one question he asked me, which I'll never forget, is, do you know any person who's ever had alternative views on this subject? And yeah, as expected, we simply didn't know anything else besides that which was standardized. So that just, made me realize something, that we tend to focus on mainstream opinions, mainstream perspectives, but rarely do we ever take time to, let's say, dare to think for ourselves and to see things for ourselves using our own lenses. Because I'm quite confident if a person takes time to observe things on their own and get to see the entire issue from various perspectives, from various people, definitely you get to, let's say, tell a different story. For you to realize that, nothing is ever absolutely certain. There's always room for people to see more. So I think a word of advice that I can give to people who wish to learn this thing: appreciate the fact that you do not know everything, and most likely you will not know everything, and always leave room for you to learn something new. Always try out things, always dare to think for yourself, and never doubt the power of your observation. If you see something not making sense, do not force yourself to conform to that which makes sense. Sometimes that's how inventions are made. Most people, they had the gut feeling that, let me just try this out. Maybe it will work. And yeah, it worked. So I think it is still possible up to this day, as long as you're willing to do so. Just open yourself up to the experience.
Yes, thank you so much. Indeed, it's very encouraging to continue learning and doubting what you know, is it true or not, and always be open. Yes, it's very nice. Thank you so much for this advice. And as you mentioned that there were some maybe difficulties in the way that some people pursue differently if you start having different mindset. That's actually a problem for our society, that everything should be framed and to the normal beliefs. And if it's something different, then it's either strange or not possible, or maybe inappropriate in a way. And could you please share with us what difficulty did you encounter in the process of creating an actual working generator?
So I think the first challenge that most people face when they're in the field of, let's say, these overunity machines or field-free generators, the first challenge, I shall call it the "it is not possible" challenge, in quotes. It is not possible challenge. Like, the moment you approach somebody and you tell them, you know what, this will work this way, if it doesn't align to their, let's say, normal system of logic, most likely they'll not really, let's say, appreciate it. And yeah, they will just, sideline the idea. And that's why I always say that that's the danger of being an expert. Because when you consider yourself an expert in thinking systems, you become complacent. And with complacency, there comes the reluctance to learn. You start to think, you know what, I think I figured it all out. So if it's not aligning with what I think it's the thing, then definitely it cannot work. Of which that's not the case out there. Many things can get to surprise you, only if you choose to be surprised by them. So I think the first challenge is that of, let's say, lack of acceptance, because you discover the people who really, let's say, sometimes not buy into these things, they're the very people with the possibility of, turning things around. So I think when you're able to overcome that challenge of convincing people that it actually does work, you then come to the second one, and that's something to do with economic resources. I'm sure most people, if if they are, of course, quite familiar with the story, they should be sort of well versed with the Wardenclyffe Tower story. Of course, it's one of the projects that the famous Nikola Tesla didn't get to finish. The Wardenclyffe Tower is building in Longshore Island. One of the things that held him back at the very foundation of it all was just lack of economic resources. So there's this very weird thing which happens in the field of invention that most of the times the person who has the idea rarely gets to have the resources to execute the idea. But then most of the times those who have got those, let's say, insane ideas, most of them do not find themselves in the position to execute them, maybe due to lack of the economic muscle power or maybe due to lack of the resources, which is not a bad thing. So I think the next challenge then, or the next difficulty will be then, let's say, networking with the right people who can get to assist you to make it. And I think that's one of the things that I've had to deal with as well, because you discover that no person wants to risk, let's say, their hard-earned money or their wealth on something that hasn't been done before, and that is considered to not work as well. It requires people with a high degree of, let's say, understanding. When you meet such people, they're the only people who like, okay, let's try this out and see how it works, and then they get to carry you from there going onwards. And yeah, one of the challenges, well, that most inventors get to face as well is simply understanding that it's not for approval, but it is for the progression of humanity. Most inventors, they have this sort of, let's say, mentality, the entitlement mentality. They feel as if they've done something, they deserve the praise that comes with it. Of which, if you spend a bit more time in the field of invention, you realize that no, it's not the case. Sometimes you can do a very good thing and nobody will even care. And that's the reality of, the issue. I think those are the three main challenges that people face when they're in that field. Firstly, denial from people around them. Secondly, lack of resourcing. And then thirdly, stigmatization, or let's say being an outcast in a system. Sometimes it may not be that smooth, but you simply have to hang on, be like a gardener, plant the seed, take care of it. If it needs to be pruned, prune it. If it needs to be watered, water it. One day, hopefully, it will get to yield the result. You may not be the one who gets the benefit, but eventually, some way, somehow, it will benefit those around you.
Yes, I really like your comparison that you actually do it for people. And when you plant the tree, you may not see the result of a tree being very high and tall, but you might create a shadow for somebody to rest and feel joy out of your tree. So indeed, this is like a great purpose for humanity, because more people can benefit and more people will be actually grateful for your achievements and that you worked on so hard. So yes. And in nowadays society, unfortunately, what we see is that everything is based on the money, on the numbers, on their own profit and own benefit, rather than for the great of all humanity. So, and could you share with us when and how did you achieve a working model generator? When you start working and you saw the outcomes and
So I think the very first year, when I managed to make, let's say, the very functional prototype of, the technology I was working on, I think it was sometime mid 2022. I think it was around May, June. I had this friend of mine whom I was working with. So one thing we did is we just wanted to try out the idea to see if it actually did get to work. So we simply had, little funds, as they say, start small, dream big. So yeah, we dreamt big and we said, let's just start small and then just see if it works. So one thing we did is we tried to make the very first prototype which would work according to those principles of ours, which we claim to have, discovered. So when you're inventing something through refitting, you're simply taking something that's already there, but then organizing it in a certain way, which you think will produce that effect. So for ours, it was simply a compilation of the common devices that are available to society, some lead acid batteries. We're using inverters, changeover switches, and a couple of other things, of course, that is available. But then the difference comes in the way we chose to arrange them to produce the effect that we wanted. And we're quite privileged to have somebody who was willing to test it on their house. So the house was quite a small household. It wasn't sort of power intensive. And yeah, if you're in our country, in Zim, you discover that the frequency of electricity which works this site, it's 50 hertz, and the voltage gets to be around 250. So our aim was to just power the household, of course, with the normal lighting, just light a couple of televisions and stuff like that for the period of time that we wanted to test it out. So for our trial, of course, we realized lighting a house without that much power-intensive equipment was all in all things were not supposed to surpass 1 kVA. That's like 1,000 watts. But then, of course, we were going to measure it in relation to what's regarded as normal and standard. For example, we do know that if you are, let's say, power your inverter using a single cell, most likely it should just run you a couple of days. But through our model, of course, it was quite good. It actually lasted 2 weeks of the trial. So yeah, that's when we knew that we had something that was working quite well. And I was like, okay, this is good. So in our opinion, we then discovered that now our thing gets to work, but then it just needs to be refined. Because if we lasted 2 weeks using things that we're just able to hustle around and just put together, what more if it's something or some things that are really tailored for the job, made by specific industry, manufacturing, stuff like that, that would be an entirely different story, of course. So I think that's the very first moment when I realized that, okay, our stuff works. I always remember the month. So it was the month of August 2022. That's when we discovered that, okay, yeah, we've got something that's really functional on our side. So that was just in addition to this article we had compiled. It's I think it's more or less a research article. I think I've referred to it at the beginning. It's called Perpetuum Energy Lebensraum. So basically, it's, let's say, a compilation of the philosophy of why we do what we do, aided by the research that we did to discover our principles, how the devices get to work, and how they may be a use as well to society. So it's much more of like, let's say, a preface to the devices of, like, let's say maybe you haven't seen it at all. At least if you read that, you get, let's say, clear understanding of who we are, what we believe in, and what we seek to achieve. Then when you see the device, yeah, it will now start to become much more clear and much more sensible. Because to us, it wasn't about, making a super powerful device that requires some rare elements that are super expensive. No, it was mostly about building the most cost-effective and affordable technology that can be used by any common person. Because you discover that the most people who are, let's say, underprivileged in terms of energy usage, they tend to be people in, normal households, the average households. And for those people to sometimes get their hands on these technologies, it's nearly impossible. So we were considering the fact that a common person sometimes may not be able to access these things, but can we use things that are commonly available to everyone, such that in a way they can also be able to replicate it on their own? So this was like us setting, let's say, the footsteps that others can follow. Like, you know what, we did it with just these common materials.
It's a very nice idea that actually shows your intentions for the benefit of people to make it with materials that any household can actually recreate and do it and benefit from it. And yeah, we know that so many people are in poverty situation that it would be very helpful for them. And could you, because you mentioned about the materials, what materials did you use to build the generator?
So for that device that we made in mid 2022, it was simply a list of commonly available materials. I think I'll just state them from the top of my head. If I leave any out, it will be a mistake. But we used some lead acid batteries. Most of them, I think the ones that we were using in this case, they were 24 volts, 12 volts, 24 Ah batteries. So we actually used a pair of those during the trial of the experiment of yours. And then we also got to aid the system with an inverter that somehow manages, to convert the DC to the IC as well. And there are a couple of number of things as well that we needed to the system to make it work quite effectively. I think we had to utilize a changeover switch, which came in handy as well. We also had some battery chargers that were electrical that we utilized, some 1 kV to 4 kV capacitors that we were having. We're also using some ACRs. We're also going to utilize a number of diodes, electrolytic capacitors, ceramic ones. So basically, those devices that I've just stated, they're very common devices. They're not really difficult for a person to get their hands on. Any person can get their hands on them. And it actually gives room as well for alternation, because in our case, for the batteries, of course, for our 12V24H, we're actually using some common lead acid types. But then if you investigate, you can actually even use lithium ion ones or some gel batteries. It just depends what's actually available to you. If you need to make an inverter system, maybe that will power at 250 watts, you need a battery of a less power input. If you need to power maybe a system that runs maybe at 3 kVA or maybe 1 kVA, of course, you need maybe batteries of maybe a higher energy output, maybe some 60-volt batteries, 10 Ah, if that's the case. But then what you discover is it's simply utilizing things that we very much know that they should be available to everyone. And yeah, I think I think, in my opinion, those materials that we used, they simply serve as a basis of something that anybody can do. But then, of course, not limited to that, because we chose to do that because that's what we wanted to use. But then it doesn't necessarily mean it's limited to just, the batteries that we're using. If you may have any other power source that you think will work according to that standard or produce at least the same level of power input, to run the system, that's okay with you. You can use that one as well. So the system, it's simply quite flexible. It allows people to fit in things to the schematic diagrams, because the way we operate is not that we come with tailor-made devices that we use to make, let's say, a very rigid and robust system. But then what we do is we create a circuit of how the system is going to basically run, the blueprints. We set them out. Okay, this is what we seek to produce as the output. So what output do we need? We need this. But then it's not really, let's say, restrictive in the kind of materials that you need. We simply give you the parameters of what you exactly need to use to produce the effect. But then, of course, a whole range of power sources can be used. A whole range of inverter systems can be used. A whole range of, let's say, capacitance as well can be used, as long as it's going to serve your system quite well.
Thank you so much. And you mentioned how it works, but on what physical principle does your generator work?
Of course, just like any other device, there are some certain principles that it actually has to observe. For example, the principles of energy conversion. You've got a battery with the chemical potential energy. From there, you get your electrical power. Then it also follows some principles of electrical power conversion from DC to AC. That's according to standard as well. But we actually had to chip in an interesting number of phenomena as well, or let's say strange effects. So what you really discover about electrical systems is there is actually, let's say, a set pattern of how they're set to operate. But then somehow, there are some interesting circuits that if you make them in a certain way, they do work in a very, let's say, awkward manner. So one guy of inspiration to the circuits we're making, his name is John Bedini. He is quite a famous inventor. And one of the circuits that has been sort of well known for is something known as the schoolgirl circuit. So what the schoolgirl circuit does is it seeks to allow amplification and conservation of power within a circuit. So in normal, let's say, day-to-day talks of electronics and stuff, that should not be possible, because with usage of a power system, the power is supposed to be lost due to the work done, due to heat losses and other miscellaneous sources as well. But then he sort of, let's say, structures the circuit in a way that allows conservation as well. And I think he also came up with this very interesting effect, which is known as the splitting of positives effect, if I can call it that way, because it's not conventional, let's say, science. So there's no name to it, but then people who are in the circles, they do know how it works. So the splitting of positives basically looks at how when cells are organized in a certain way, they do get, let's say, to power a system, but then at the same time regenerate the power that they would have used up. So the question then becomes, what regenerates this power? So according to John Bedini himself, when he initially did the experiment, he couldn't really find, let's say, the pinpoint answer to it. But then he used an umbrella term, if I can say, a general term. He simply said perhaps it can be powered by some radiant forces that are out there surrounding us in the universe due to their great abundance as well. So what you discover is, in the process of making the circuits, sometimes you get to a point whereby you do structure a circuit in a certain way, but then it produces very strange effects that allow you to conserve energy. So yeah, I think that's one of the things that we utilize in our system, unique circuit designs that, let's say, produce very interesting effects of energy conservation and amplification as well. Then I think the other thing that we get to utilize, I think, is charging of the devices themselves by radiant energy or atmospheric electricity, if I can call it as well. Many writers as well in the fields of into machines have done justice to that one. Even the famous Nikola Tesla did it. People like John Braden did it. People like Don Lee Smith did it. They actually get to, let's say, clearly explain how people can harness energy which powers the woodwork of the universe. So as I said before, as humans, we get to see, let's say, 0.0035, less than that actually, of the available, let's say, electromagnetic radiation out there. But then you discover that electromagnetic radiation is something that surrounds us a lot. And the power that it holds, let's say, is more or less very crucial in the woodwork of the universe. So having a method, let's say, of getting to tap into that energy will actually give you the potential to recharge or power your systems indefinitely. I can say it's sort of, let's say, the prime or the king of renewable energy that most people never talk of. So most people got to design, let's say, these radiant energy harvesting circuits. They're very interesting designs to it. One person who has managed to compile, let's say, some literature on that stuff. It's a man by the name of Don R. Kelly, and he managed to state how these devices work and how they can be scaled up to even higher levels as well. So we also leverage on that power of radiant energy. And on top of that, we also get to use some principles of telluric currents in the earth. So telluric currents, they're basically naturally occurring electrical currents that are more or less on the surface or below the surface of the earth and transparent to the earth. So with the right equipment, yes, you can actually get to harness it, and you can also get to, let's say, recharge your system, or let's say power it if it is scaled up to the big enough level. And I think the third is all leverage that we get to utilize in this case. It's the power of, let's say, exclusion zone water. One man who did a very, let's say, well-versed article, or let's say well-versed research actually on that subject, is a man by the name of Gerald H. Pollack. So what you discover about Gerald H. Pollack is he's one of those people who always had the simple questions that most people could not really answer. And one of his questions would be, let's say, for example, why is it that sometimes when you spill water on surfaces, it tends to coalesce or come together, the water droplets get to come together. But then on some surfaces, they actually get to disperse. And you also ask more questions about water. For example, why is it that if you take lukewarm water and maybe slightly warmer water, the warmer water gets to freeze faster than the lukewarm water? He investigates the issues of, basically how water functions in, let's say, our day-to-day lives. And I can say he's one man who has managed to come up with possibly the greatest discovery of our century. Most people, of course, not really, let's say, know about him or his works, but I really respect him as a researcher and as a water scientist. And some of his principles as well, which he managed to, let's say, come up with on the concept of exclusions and water and how it can be utilized to power systems is one of the things as well which we use to, power the system. So I think in total, I've mentioned four things. Firstly, it's unique circuit designs aided by radiant energy, also aided by the power of exclusion zone water and telluric currents powered by the earth. So it then becomes, let's say, it's more or less a package of unique forces that are found on the earth or unique energies that are on the earth, because we're extracting energy from the lithosphere, that's the earth, the hydrosphere, that's the water, and the atmosphere, that's the air around us. And then we bring all those to aid the unique circuits that we have to produce the power that they have to produce. So I think, I don't know if you may have questions to that, but then I think in short, that's how basically our technologies work. An integration of natural forces to produce clean, renewable, and pure energy for people that gets to improve their livelihoods.
Yes, because we have those power sources, right, available for us. So why not to use it and benefit out of it? Because they are free, they're available. And could you please explain the process or reaction that take place inside your generator to produce the power?
So normally we start off with the battery systems. They're organized into system A and system B. So just like any other battery, it's basically, let's say, an electrochemical production of energy. So basically, we use the electrons that are generated from those reactions to power the system, and I think that's standard. But then, of course, the key then remains on how we get to recharge them, as most people ask, because for most people, when you utilize energy, of course, just to be replaced, energy can just come from the breeze. This is actually particularly true. So the way we then get to, let's say, recharge this core, I'll give in reference to, let's say, the reference of exclusion zone water, which we use. So what you discover about the exclusion zone water is it's actually, let's say, more or less a fourth phase of water, as Gerald H. Pollack would put it. So this fourth phase of water, it's more or less a lattice structure of water that allows electrons to be mobile, because basically the molecules of water, the hydrogen monoxide molecules, they get to be organized in more or less hexagonal lattices that spread out on the surface, mostly of, let's say, hydrophilic substances. So on that end, there now becomes that concentration of those electrons. Then inside, they get to be a concentration of the hydronium or hydroxonium ions. Basically, they are positively charged. So whenever there's, let's say, that polarization of positive and then negative on the other end, automatically you have, let's say, a potential difference or basically an electromotive force that allows you to power something. So the key then is to be able to arrange a very standard, let's say, cell working on the principles of exclusion zone water or fourth phase water that allow you to produce as much current as possible to recharge those batteries. Because for you to be able to recharge something, it simply has to be, let's say, of a higher power value than that which you're sitting to charge. So basically, we actually have to look out for overcharging. That's one thing as well. And at the same time, you simply need to be having the right values that are slightly over that, say, that are slightly over the system A or series of batteries that we wish to, let's say, recharge. So when we actually have these exclusions on waters that we have, the key then is to be able to place the right cathode and anode. So basically, you need a key of, let's say, conducting materials, but then one has to be slightly more conductive than the other, so that you're able to consistently recharge the batteries. So in simple terms, while system A is working, system B is at rest. Then in the event that the changeover switch switches from system A to system B, system A now gets to be charged by those processes, as I've mentioned. It's a couple of, in fact, it's a triplet of forces of nature that are charging it. Firstly, the power of that exclusions on water. Then at the same time, we have radiant energy harvesting circuits that allow power to be, let's say, fed into the battery systems. Then at the same time, we use the currents of the earth as well to charge those batteries. So once system B has worked up to a certain critical value, the changeover switch then flips from system B back to system A, and system A would have recovered as well. Firstly, from those three forces as well, plus the arrangement of circuits that allow, let's say, natural revamping of energy. For example, the splitting of positives. So then it becomes an alternation of, let's say, system A, which is like a connection of batteries there, to system B. And in a way, by alternating, we give room for one system to recharge whilst the other one is at work. And then all the other now comes to work, the other one becomes the recharging, let's say, system. So what you end up having is simply a long-running system, because definitely if you're able to consistently feed your system and at the same time you're able to extract reasonable amounts of energy that do not allow exhaustion, it will more or less run indefinitely. But then indefinitely won't be a right word, because of course things can be susceptible to, let's say, maybe damage, electrical faults and stuff like that. So I think, yeah, basically that's how it runs in terms of the processes of what really gets to happen, in very simple terms that people can get to understand and be familiar with.
Yes, thank you so much for sharing. And in terms of the power, how much power is it capable of producing?
Okay, so from our trial runs, as I mentioned, the very first one that we managed to make, the one in August 2022, it had a power output of 1 kVA, or a single kilowatt. That's like 1,000 watts. But it's not limited to that. That's what we were able to prove, actually. And we actually have a smaller one as Oshrex on 500 watts, but then it is actually scalable, because the thing about power generation is, as long as you have the same forces and as long as you're able to harness them, you're actually able to scale things up to a level that allows you to harness more power. Because to us, basically, the reason why we chose to stick to the 1 kVA limit is that's basically the power output that we could have easily tested on our own side safely as well. With also respect, of course, to the level of resources that we had at that time, 1 kVA was the best shot for us. But then is it limited to that? No, not exactly. It is scalable, because basically the same principles can actually be used for any other higher order system. It's not particularly limited to that only. As long as you simply have, let's say, the right equipment to harvest those forces of nature to power your system.
All right, thank you so much. And where do you see the prospects of using it? In what specific areas can it be used?
I'm a person who's very down to the earth, and I simply believe in, doing things for the common people. So I'll mostly be, roaming around on households. So basically, what you discover about the common people is they do require energy for a lot of things. For example, you do require energy for heating of the household. You do require energy for lighting. You require energy for cooking, for communication, for transportation, for entertainment. Like, energy is one thing that if you do not have, things will not really, let's say, go smoothly for you. So definitely that's one area of, let's say, application that this thing can be used for. Basically the simple households that really get to struggle with this, because one thing about, let's say, achieving a creative society is we have to place every human life at the forefront. But then for us to do so, we have to come at a stage of higher consciousness. So most people, they work at lower levels of consciousness, whereby they're survivalists. So if someone is a survivalist, they get to sacrifice good things such as human life for material things to survive. But then if you're able to chip in and be able to provide them with those simple things that, let's say, they do need, things get to be much more smooth for them. such that it will be able for them to understand, let's say, the philosophy that we sort of present to them of placing human life at the forefront. Because it's difficult for somebody who is, let's say, severely impoverished to believe that human lives are at the forefront, because it begins with them. When they look at themselves, they see themselves as neglected. Nobody cares about them. I'm here. And they have to blame others for what's happened to them, even though it may not be others' fault. They always want to blame somebody. That's how most humans operate. They want to place the blame on something that is external so that they themselves feel a bit better. And in doing so, they then fail to realize that no, fundamentally, society is for collaboration of humanity, not for one person to feel as if they're above or below another. Because once you feel like so, you abuse the next person. So basically, my philosophy, or let's say my perspective was, if we're able to cater for the common person, make sure that all of the things that they may basically need at the very basic level are sort of, let's say, taken care of, then definitely their minds get to elevate to, let's say, a better level of consciousness. So they understand, no, it's no longer about materials, but then now it's much more about the progression of humanity itself. So that's one thing that I was really thinking of when I did this. And I think it's also a technology that is open, let's say, to industries, because most people in the industrial sectors, they've got a lot of transportation in freight to handle, they have a lot of heating and manufacturing to do. And I think definitely if they're able to scale this up, it should be of use to them. Of course, lots of developments and lots of innovations will actually have to be done to ensure that it's usable by people at the industrial level. Because as of now, we're just simply focusing on households. But then, yeah, it can be scalable to that extent as well. And I think the technology of solve of fuel-free generators, it also can be applied, let's say, in unconventional fields. So there's this field known as electroculture, which may be quite familiar with some. And basically, electroculture or magneto-electroculture it is put across by the professionals in the field. It's simply a field which seeks to, let's say, stimulate or amplify plant growth by sort of manipulating the electrical and magnetic fields. So one of the people who have been, let's say, very popular for that experimentation was this guy known as Justin Christophe Liu. He was French, and yeah, he's one of the people who wrote, let's say, research articles on now using, let's say, naturally occurring electrical currents and magnetic, let's say, forces can be utilized to enhance plant growth. So the funny thing about magneto-electroculture is we can actually get to substitute, let's say, lots of chemical fertilizers that may be expensive through use of that as well. And it is also possible for a being as well to be able, let's say, to utilize it to control pests and other diseases that may be affecting, the crops. One man who did it was the Russian by the name of George Lakovsky, and these Lakovsky coils. He's one man who was very popular for utilizing, those special coils to, let's say, you plant with diseases and sort of, aid plant growth. And in my belief and what I've seen actually, if those, let's say, forces are utilized together, magnetism and electrical energy, if they're used accordingly, they can actually get to allow people to solve, let's say, basically most of their food crisis that they may be facing. So for me, it then stems not only from let's say from an energy perspective as well, but then it also stems from a humanitarian perspective that if the energy is more or less accessible to everyone, not only are they able to cater for their, let's say, common needs or basic needs that they may have to handle with on a day-to-day basis, but then they're also able to produce the food for themselves. Because one thing about energy, it's actually something that is interchangeable. If you know how to use it, you can literally take your life back, because that was the idea behind the making of fuel-free energy generators. You simply wish to make a person be able to reclaim their lives back, to be able to own their fate by being able to control the means of how things are produced for them and the needs which get to come their way.
Thank you so much. Actually, in Europe, especially because I'm from the Netherlands, it's very common to have to install solar panels on their private households so that people can benefit out of the own produced energy, and they can implement it for their household. And in terms of the alternative energy, what are the advantages over the alternative energy sources known today? For example, wind turbines, solar panels, geothermal plants. What would be the benefit of having your device in the household?
I think our unique, let's say, proposal when it comes to our devices that we offer, it's it's mostly about the ownership itself and decentralization, in the sense that when you have got your own, let's say, overunity system, you are not really particularly bothered by what happens outside in terms of, let's say, energy transmissions. It gives room for many people to be decentralized and operate in a very affordable manner. Because if you look at the cost of setup, let's say for solar panel systems and everything else, compared to that which you may similarly do with simple energy system, it is actually much more competitive than that. Proposition systems, they're quite good as well. So it's also more to do with their cost effectiveness and affordability in attaining that ownership and decentralization, if I can put it that way. And I think also it's much more to do with space consumption. It's just saying it's a common thing to be putting them all over the roof. But then the thing is, even though you've put them on your roof, will they be still enough now? That's another case. So I think over energy systems, they are much more, let's say, compact and robust. They are simple systems that are much more condensed together, but then with the ability, of course, of being able to produce a lot more power than the common, let's say, energy systems. And I think one thing about the most common renewable energy sources, let's say the wind power, the solar power, they are actually, let's say, in a way, condition influence. For example, if the weather is to be super cloudy, then definitely, yeah, the power output is going to be influenced if you're using solar panels and stuff. If it gets to be less wind, of course, it's going to be affected. But then the thing about these fuel energy generators is come hail, come thunder, it's all good because their effectiveness is not particularly dependent on, let's say, a particular condition that should be available in the environment. They simply work, let's say, spectacularly well in any environment. Of course, maybe one environment may be slightly better than the other, but on average, it's roughly the same. It's not really impacted like by the different environments. So I think that's one. It's it's one of the set of reasons that I can give as to why the systems that we may be sort of designing are quite effective because most people do want it, but then the question is, even though many people want it, how many can get it? So the question then comes in trying to make the good things accessible to every person because every person wants something that's good for them, even though they may not have the means to attain it. So by making something that can be monopolized, accessible to everyone, that's actually beautiful. Because when we speak of these, let's say, overheating systems or fuel-free generators, they're basically in the same league with things such as, let's say, sunlight or water because nobody can monopolize sunlight. Everybody can experience the beauty of sunlight. You simply have to spare your time and maybe, I don't know, a bit of energy to walk outdoors and just enjoy it. You can also get to drink, as much water as you want. But then, of course, these days there's this challenge of accessibility of safe, clean water as well. But normally, such things they're supposed to be, let's say, accessible to every person. So I think energy should actually strive to be in that same, let's say, space as well, in which most things they get to be accessible to every person because they're good. Every person wants to have a house that has adequate lighting. Every person wants to be able to eat their houses sufficiently. But then not being able to, it honestly really sucks. And honestly, I think it's one of the things that can get to, let's say, derail the course of humanity from progressing to actually being creatures who are suffering, let's say, devolution, sort of thinking in a very animalistic way. So by being able to make energy, which in my opinion, as I've always said, is the core of civilization, more accessible, then you actually give the human more potential to be able to do what they may really want to do. And I think for any society, that should be a common consensus. Every person wants to have the ability to do what they really believe in, as long as it's for the greater good of the system. And if they're given that platform to do so, then definitely, yeah, it should be a beautiful thing. It should be. So I think that would be my idea on why, these FFGs, as I would like to call them, they should be more or less adopted compared to the common systems which are utilized sometimes.
Yes, thank you so much for sharing. And in terms of the environmentally friendliness, how does your generator affect the environment and how actually environmentally friendly it is? How safe is it for humans to use in their household?
Most electrical, let's say, devices come with a risk of, let's say, harm from mishandling. But when handled appropriately, does it maybe pose any risks to the people who will be using it electrically? If handled well, then there should be no concern. So it now lays, like the burden now lays on the hands of who are using it, if they're going to be handling the item as expected. If they do so, most likely there shouldn't be much danger expected. Then in terms of environmental friendliness, as I said, we're using commonly let's say, available materials. And I did mention that for our model that we made way back, we're using the lead acid batteries. So when you discover those kind of batteries, on our side, they actually have a sort of like a problem when it comes to recycling as well. So for now, I think that's simply the stumbling block that the model may actually have, because we're using things that are easily available to just make something that works quite well. But if we are going to produce energy the standard way, do we expect there to be problems? No. Why do I say so? Because we can actually discover, Kuti, if we are going to be utilizing, let's say, the battery systems, if we're going to be, let's say, so effective with our proposal of, let's say, the concept of exclusion zone water and making water batteries, we can actually have a very clean energy source that causes no harm to the environment at all. Because once people, when they hear the concept of water battery, they'll be like, no, this man is crazy. How can that happen? Well, actually, it is actually very possible, according, to where we are right now. It's actually very doable because according to the, let's say, illustrations that we have of how things should be like, definitely every company should not pose, let's say, environmental risks at all. It will be purely, let's say, aqueous, immersed in water, very safe materials, or entirely water-based itself. And then mostly it should be metallic. And then the metals themselves, they should not be in any way difficult to recycle. So I cannot really, let's say, imagine any environmental threat in a way, unless, of course, if people use the technologies choose to be, let's say, negligent. Yeah, that way perhaps maybe it becomes environmental problems. But if all is going to be well, if the right, let's say, mode of batteries are going to be used, powering the right kind of inverters, powering, of course, the right kind of equipment, then more or less the environmental harm should be negligible as well. Yeah, that's the perspective that I have on that one. But of course, time will tell, because sometimes the risks that come your way, you cannot really conceive them. Because as inventors, we have a problem that we are overexcited when we make things, such that we want to scale things up really quickly without really, let's say, perceiving all possible problems that may come from that. If there's always room for you to improve, seek to improve. If it was a 1% danger, you have to cut it to maybe 0.0001 danger. That's how we progress as people. So I think, yeah, as of now, we have got the right, let's say, schematics of what the proper things should be like. And if those things are to be utilized, then definitely no sort of environmental harm should be expected from that.
And you mentioned about room for improvement. Do you foresee yourself any limitations or drawbacks in your technology that you consider important?
Well, one of the limitations that you deal with whenever you are handling something that gets to transmit power, it's more or less to do with efficiency. Efficiency is always a bug that concerns most people. And whenever you've got those challenges, let's say, of concerns, one thing you wish to do is to, let's say, minimize the possible impacts that you may have. So let's say, for example, in our case, we may be having an efficiency of a 98%. It's just hypothetical, not an actual. But then we wish to strive to, do more, get to let's say, a higher level. You have to be able to use the right, let's say, materials that will allow your system to be quite sustainable and quite effective. And then the question then becomes, how are we able to, let's say, do that? So from our end, we've been, let's say, doing a lot of research on that, on the best materials you can actually use to make the systems much more improved and much more effective. And I think one main really stands out in that, let's say, area of investigating super effective materials. It was this man by the name of Dave Dodson. He was actually an Arizona farmer who actually used to do a bit of mining as well as a side hustle, if I can say. And one of his interesting, let's say, discoveries, even though not actually standardized, is the concept of orbitally rearranged monatomic elements. So what these are simply, let's say, it's an element. Basically, it's an existing substance in a very pure form at a very particular level, whereby it has got particles of the same nature. And the very fundamental, let's say, thing about this material, known as the ORME, if I can call it that way, it more or less behaves as a superconducting material. And whenever you're in the fields of, let's say, power, energy, and electricity, when you hear about superconductivity, then definitely that's a holy grail, because most superconductors cannot really exist at room temperature. They exist at very low temperatures that are not, commonly around us as human beings. So what this guy managed to do was to propose a possible material that can be, in a way, utilized for the superconducting materials. So do we need that? Definitely. from my side, yeah, we do need that. I think that's one thing that can really make the system progress to the next level. Because if we're really to cut out any sort of inefficiencies, then we won't really have to worry much about the recharging aspect. Because the reason why we have to worry about revamping the system, recharging it, is simply because at the very, let's say, at the very first of it all, it all lies on inefficiency. Because if something is very efficient at the highest possible level, you don't really have to worry about consistently aiding and, let's say, pumping, let's say, input power into it so that it works at the best possible level. But then, of course, if we are to attain that level whereby you've got attained, like, the super effectiveness of conductivity of energy and stuff like that, then definitely you can then start to worry less about the recharging, and then just tend to focus more on how the system will just best work for you.
Thank you. And what do you think needs to be done to enable all society worldwide to make the transition to a fuel-free energy, in your opinion?
So I think that's what I can safely say first. Quickly, one thing that we truly need for this thing to be really implemented, it's the right ground for it to, let's say, work on. And I think the creative societies, in a way, they offer that right ground. Because if they're to be put on the right ground where people are already, let's say, in collaboration and they're working quite well, definitely they should not be able to cause more or less of the disruption there. Because one thing you understand is if society is mostly based on profit, then this thing can actually tend to be a hazard. It's a threat, actually. It's not more of a useful technology. So, firstly, you need to find a space in which all objectives now point towards upliftment of human life and, let's say, protection, securing, and improvement of the lives per se. Then that way we can safely say, you know what, these lives are going to work together. Human lives are going to integrate so well with the technology that we have, such that no person will be posed, let's say, to a possible danger. And I think one thing as well that we really need to do to ensure that there is this deep transition, I think it's open access to the knowledge itself. The one common concept that exists in the field of, let's say, these fuel-free generators, it's the issue of, let's say, targeted individuals. Some in the past, they have really done great things. Some people may be familiar with the story of this man called Stanley Mayer. He's a man who lived in the Americas in the 20th century. I think it's 1940, somewhere about the 1980s or 1990s. And there was one guy who was like very much working on water-powered vehicles. But then it didn't end so well. Why? Because he became a target individual. How it all ended is that he was actually poisoned by who? It's not known. And there's a list of other targeted individuals as well who actually existed. People like Andrew Murray and the Radiant Energy. He had to survive many attempts in his life as well. So one thing which we discover is the people who have this know-how, they position themselves in a way that exposes them, they say, to a lot of risks. Because the knowledge that they have, it's, let's say, it's not so useful to some people who benefit from the way things already are. So by them being the only people who know such knowledge, they're easy to target. But then it would be a different case if such knowledge would be, let's say, distributed openly and freely to everyone, such that it becomes more or less like, let's say, a spiritual practice. Let's say, for example, prayer, right? If, let's say, maybe we have got a religious group of people who want to pray, no matter where they are in the world, they all can pray because they've mastered the fundamentals. And I think that's the same thing as well that needs to be, let's say, a level of operation in this field of fuel-free energy. People need to understand the principles openly, such that no matter who a person is, they're able to do it on their own. Because if people are so concerned with profit, for example, if I'm so concerned with profit and I choose to keep it to myself, I expose myself to really great risk because it's easy to target an individual. But if it becomes a societal thing, whereby it's basically known by everyone, you cannot just wipe off a society of the rest of theirs. That's really extreme. If someone may be able to do it, well, that would be difficult anyways. But it's actually a much more safer move if there could be an offer of, let's say, an open access to the technology. So I personally would want to function as a distributor of the technology, but then this is not a one-man job. This is more or less of a movement, and the movement is best effective if most people are actually involved in it. So I think there's a deep need for people to really appreciate uh, the possibilities that the technology of fuel-free gets to offer. If the technology, of course, it's, let's say, openly accessed, most people can get to improve their lives on their own because, as I said, it's something that any person can get to do with materials that are available to them. So from my end, I think I'll do people the honor of giving them that knowledge if they wish to get it. I'm not a person who's really, let's say, economic with the knowledge that I have. I give it away freely to any person, of course, who may wish to know it. So I think if people work at the same level as well, at which they wish to freely give away things that I offer to society, then definitely people will get somewhere. Because what people need is it's a lot more of good people. People always want to be successful and important. It's a good thing, but then it becomes a problem because if everybody wants to be the guy at the top of it all, then people are going to pull they're going to put the fabric in different directions. And the fabric is put in different directions, most likely it will tear into pieces. So to avoid that from happening, we need to understand that society at this point, it doesn't need a lot more of successful and important people or centralization on a certain group of people. But then we're at a point whereby we need more decentralization and a lot more of good people who are willing to go on the ground and do a lot of good deeds out there. If we have that, then definitely, I have no doubt these things should actually go out there and help people. But then it all starts with the willingness to accept, of course, this task that we have and doing the best we can to bring it to the world, of course.
Yes, thank you so much. Indeed, it's all about people's choice, right? What they decide, and that would be our let's say outcome. Because the Creative Society is also based on people's choice. So, as a volunteers, we offer them the bright future, right? The possibility to have the like human life placed at the highest value, and removing all the concept of the consumerism. But again, it's people choice, and as soon as they realize and wake up and understand that, then we have it. I really appreciate the time and your answers and all your insights and full information that you shared with us. It was very interesting listening to you on your has like a wider perspective on looking into this and how you can be in a way open-minded and also naive and let the doubt come in, but then it will challenge you to go further and further and never give up and continue working on your idea for the benefit of the society. It's very inspiring, and I really appreciate your time today. I'm sure that our viewers as well enjoy listening to you. We wish you all the best, and hopefully, we hear from you and your a product being even more developed and being used in most of the households, and that people can actually benefit out of it. Thank you so much for your time.
Well, I would also like to thank you for having me here. As I said, it's actually really an honor to be having people like you, people who wish to genuinely learn something new and get to make others know of it as well. Because one thing I've discovered about information in our age, it's more or less treated like gold. People don't share gold. If it's your gold, it's your gold. You don't share with it. Like you don't share it with society. It's your own will, hard-earned gold. You keep it yourself. But one thing about the creative society, in a way, I think is that one platform whereby people go out there and then they choose to bring several pieces of information that they have, which are valuable, and then pull them there so that any person who wishes to learn something, they actually can get to genuinely access something valuable to them. And I think in the end, it's going to be more or less like a jigsaw puzzle being built. The jigsaw puzzle, you've got these lots of pieces that are all over the place. But the more you come together, the more you try to fit in and create a nice picture. At the end of the day, you come out with one piece that's really excellent and really brilliant. And I think that's one very special thing about this society that we're in the process of building. I'm really proud to be here and sharing, knowledge with others. I also had to learn from others what they had to share, and I enjoyed what they also had to teach me in turn. So I think, in a way, it's me giving back to people who also gave me something new to learn. And yeah, I'm really proud of it. And to whomever will be listening to this, I'd like to say thank you for just choosing, to be open-minded and then get to discover something new out there, which can just get to genuinely improve your life. And as I always say, just keep on keeping on. One day, it will all make sense in the very end.
Thank you so much.
You're welcome.